Hello and welcome back. So in Chapter 2 of Python, we look at the IPO table, or an input processing and output table, where anything is classified as any data that is received through the program, so either from user or from the code while it's running. And so that would go in your input, and then the process would be any calculations or anything that the program would do itself, and then the output would be something that you're printing to the screen or perhaps a value. We can also use the # or the hashtag symbol for any comments inside the Python code, where it ignores it and it keeps going. So you could put like minor comments on what each code does to keep yourself on track. And then we get to the actual variables, where we have to name using letters, numbers, and underscores when we're naming, but we can't start with a number. So we have to start with a letter of some sort. And so we can see down here that days a month would work, days per month with underscores would work, subtotal 1 would work, whereas third place would not work because we have the number at the front. And we can't use any # or slashes inside the naming of variables because the code thinks it's something else, which we'll see later. So in int and float, for int we're going to have full numbers such as 1, 2, 3, 4. Float we're going to have like numbers with decimals, so 2.5, 2.75, 2.2, and so. Then we get to the input statement, where the user inputs from the keyboard. And so, for example, in variable 1, where we're inputting in the prompt, typically that's for any words or like names that you're trying to get from the user. And then we have variable 2 and 3, where we're getting numbers, and we can either get it as a whole number or we can get it as a float, being a decimal. And typically we use the int for any whole numbers, such as like for a ticket, for how many tickets do you have, because we can't have half a ticket. And so that goes back to common sense, in my opinion. And then we go back to like prices, and we could have either a whole number price or we could have a decimal price. For like $2.75, we would use the float. We could also use the float for $2. So it gives us more flexibility than just using the int. And then we get some calculations operators and operators that Python uses. So we have the add and subtract, multiplication and dividing. Then we have the exponent, and we have dividing with an integer, where it gives us a value of how many times it goes into it with a remainder of whatever that number may be. So it's important that we use these operators because, like in math, we have a less than and greater than equal to, whereas in Python, we have to use these operators to get to the less than or equal to, or greater than or equal to in general. We have to use the double equal sign. And so let's look at some code. So for Python, we have in Chapter 2, I know I mentioned in Chapter 1, where your casings is very important. You want to make sure that your casings are very consistent, because one simple error can throw your code off and it won't work. So it'll say like a syntax error or something, and that will make you very frustrated, especially if you're there for a while, for close to 3 or 4 hours, trying to make sure that it's not working. So for example, we can use the int statement here for first name, as I showed. The user will put in their first name, the user will put in their last name, and it'll print those values. Well, then, since Python reads top to bottom, we can state that A, B, and C are equal to these values, and it'll do this A plus B equals C, and it'll print the value here. And then we can do another calculation, and it'll print the value here. But it'll keep these values the entire time. However, the C value will change just because of the different calculations that we're doing, because it reads top down. And then we can go a little bit further, and we can see that we're going to get even more values using the C, using the A and B's to get to certain values. And we can see when we run the code that it displays all of the code, all of the lines that we need. So if my name was Dave Smith, it printed out my name, and then it went through each line all the way up to 7 of each of the code 4 that we had. So we can see that 1 was a decimal, 1, all the rest of these were whole numbers, and we can get that process that way. If we look at an example, we can see that we want to use the total price, and so the user at the store is purchasing 4 items, and we want to get the value of each of the items from the user, and then we want it to display the subtotal, we want it to display the sales tax, and then the state tax, and then the grand total. And I state that the state tax would be 12% and the sales tax would be 8%. And so we would have to display our variables first. So we want the user to input the prices of all 4 items that they have. So we have the prices of all 4 items. We used the float statement because we have a decimal. We use the input statement so the user can use something from the keyboard. And then for the subtotal, we typically just take all of our values and just add them together. So we have that subtotal, and then typically in taxes, or like if you go to a restaurant or something, or even a store, they'll give you a subtotal, and then they take 8% or even 6.5% of that subtotal, and then they add it to your total for taxes. And so we have to think about that mathematically in the same manner, where we have to take that price and add it to it. So at the end, we can see that I take the subtotal, I take the sales total, and I take the state total, and I add it to the grand total. So that will give us our final grand total price. We can see that we could also have written the code in a manner where we state the value. So for example, we could have done sales total equals to subtotal times 0.08. We could have done the same thing there and it would have done the same calculation. However, that being said, I prefer to just use variables inside my code. So I just stated that that variable is equal to this value, and then it'll follow that value all the way down. And I don't have to worry about making sure that I change it or anything. Whereas we could use one where we could go out a certain part of the code and we could have the user put in an input variable where it gives them a value the first time, and then they could put in another variable and it would give us another user another variable. And we could do that same thing. So for example, we could take out what's the sales tax. We could put in a float input where the user has to put in their sales tax, and using it in this manner would allow us to do that. We would just put in a float input, what is your sales tax? And it would take the sales tax with that value that the user put in. But we would want to make sure that it would be a decimal, because if they put in a percent sign, there's going to be an error and it's not going to run the code. So if we save it and we try to run our code, we can see the first line is asking us in line 8 to put in price of our first item. So if we say $4.75, our second item, let's say, was $16.50 or $26.50. $16.75. And let's go something bigger, 108 cents. So we can see that it did our subtotals of all the values, and then we can see that our sales tax was $11.85, and then our state tax was $17.77 about. And then we can see a grand total of $177.70. And so we can see that that code works. Another thing to note, when you're in Visual Studio Code and you want to clear this terminal down here, you can type clear and it'll clear that terminal, and so you have a clean page in case you want to take a screenshot or a screen snip of it. And that's super nice, especially when you need to submit it for work or something like that. We can do another values. So for example, we pick higher values. We could do 1,000, 2,000. We could do 3,450 cents, and we could also do 5,000. And we can see that we have a lot higher numbers in this case that we're doing. And so the code runs in the same manner. Long as we have them stated, we can use the code to follow throughout the rest of our problems.